Thank you for coming to my talk, and today I'll be introducing my research on using machine learning in cultural psychology. There are two parts to this talk. The first one I'll be describing, giving an overview of how I think machine learning can really contribute by elaborating on this idea of cultural models. And then for the second part of this research, I'll be looking at a specific example of using cultural models for theory generation and theory validity testing. And so before I really get into the talk, what is machine learning? Some of you might have heard of this term before, some of you might not. But basically when we talk about machine learning, we're really referring to using a computer system to perform various kinds of tasks without explicit instruction. So for example, if you have like a lot of stimuli data set, you want a machine to identify like a tree, a car, a person within this like photograph, for example. So this would be an idea of computer vision. There have been some models I think that developed to play chess against like humans. And I think in medical research, we see a lot of machine learning being used to look at radiograms, to look at patient histories, and to try and diagnose illnesses or even mental illnesses sometimes from these kinds of big data sets. But across all of these examples, like the commonality is that machine learning usually involves some kind of decision or artificial intelligence-based predictive process. Basically, at its core, what it's doing is that it's looking at a big set of data and it's identifying patterns, performing statistical modeling on it, and trying to, based on everything here, give you a classification or prediction process on what it thinks someone should be or what it thinks the output should be. So previous examples of machine learning in cultural psychology have tended to use machine learning to classify or to cluster constructs across cultures. But really with my thesis, what I'm proposing is that we want to directly train a machine learning model to classify culture, to classify if someone belongs to, say, Japan or the US based on their survey data history or based on their social media usage or something. And where I feel this is important in cultural psychology is with, because it is essentially a hypothesis-blind method, what we can do is to do bottom-up theory generation to get new ideas of how cultures are different from each other. What I'm proposing basically is a data-driven approach for exploring cultural differences between cultures in a data set. For example, based on, say, a personality history, can we identify if person A belongs to the US or Japan? Going beyond participants, can we look at web data? Can we look at more complex kinds of annotations? There's this county that belongs to Canada, belongs to China. There's this song that's being produced. Does it belong to a Canadian artist or to like a Japanese artist? And so the good thing about machine learning is that once we have these kinds of ideas that we want to test, we can actually then sort of split the data. I'll come to this in more detail later, where we can test this developed model on an unseen data set for a relatively more unbiased assessment of the strength of this model. Like, is it good at what it does? And from this strength, we can then extrapolate the differences, the magnitude of difference between these two cultures, at least for this data set. And so coming back to the idea of cultural psychology, like what cultural psychology tries to do is that we try to understand the process of how culture is shaped and how it is shaped by people's attitudes, behavior, and cognition, basically psychology, right? So we're interested in a lot of causal explanations and a lot of associative explanations. But at the same time, because we're so focused on trying to understand phenomenon, machine learning, which is more geared towards predictive outcomes, towards classification, towards specific tasks, can we then use machine learning and bring it back to learning about how people are different from each other? Basically, can we use a predictive task and then bring it back to understanding, to interpretation of how cultures are different from each other? Answer is yes, and I'll get to that in a little bit. And so why machine learning? What drove me to do machine learning? Now, basically, I noticed in the literature, a lot of ideas that you have, especially in cultural psychology, they tend to come from what we know as weird cultures, right? Western, industrialized, educated, rich, and democratic cultures. And so things like interdependence and independence, for example, tightness, looseness, the people behind these ideas are very often based in Western cultures, and this kind of Western thinking tends to seep into these cultures. As a result, we don't really understand cultural differences beyond these kinds of well-tested spheres. For example, if you wanted to compare like countries like maybe Rwanda from, I don't know, Cuba or something, where you don't really have much cultural comparisons before, how are you going to do it? What's the best way to look at these kinds of differences? And I think machine learning here as a kind of methodology would be a very, very apt or appropriate method to use. So I'm not saying that we want to try and replace a hypothesis testing research or to replace the theories that you have. No, rather I am sort of proposing machine learning as a complementary approach where it's basically a quick and efficient method to look at two different cultures, two different countries from the bottom up that we can then use to devise theories on how these might be different, even if we don't have a relevant observational experience or relevant theory to kind of base our thinking on. And so I think, again, where I think this works best is with research that has sort of been overlooked in previous literature, such as non-Western, non-weird research. And sort of what I think machine learning is really good for is that it's designed to work with large amounts of data. So it provides computational solutions for a lot of big data problems. Like if we have multi-dimensional data, if we have a lot of predictors, for example, if we have a huge sample size, some of these are more streamlined towards addressing some of the problems that come with these kinds of big data sets. And so with issues like generalizability or fitting, I think machine learning is more adapted to take care of these kinds of problems. And so, and being cultural psychology, I think we can then take some of these already developed solutions and then put them to identify culture and identify cultural differences within these kinds of psychological research paradigms. And so I'm going to start from the very top. I'm going to assume that most of you here don't really have an idea of what machine learning is, what are the techniques that we talk about, what are some of the fundamental methods used in machine learning. So I'm going to give you like a very simple introduction to three methods I use in my research. Cross-validation, decision trees, and gradient boostings. Ultimately, they build on each other to sort of get a better, like a more complete model. But I'm trying to walk you through the process of like how we went about doing this kind of research, fitting these kinds of methods. So the first concept I want to introduce you to is cross-validation. And cross-validation, as the name implies, you're splitting the data and then validating the model that's built on one data set on like the unseen data set, unseen test set. And so earlier on, I talked a little bit about this concept where you want to test like the validity of predictions of the model in an unseen data set. So this is a relatively unbiased way of going about doing it. And so a very simple measurement would be just accuracy. So let's say we want to build a model to identify differences between, say, let's say the US and Japan, like very standard kind of cultural comparison. And let's say you have a data set of like n equals 2,000 people. What a very common approach would be to first divide the data set into, say, like a 75-25% difference. So like maybe 1,500 would be put to this training set, and the remaining 500 will be held out unseen in this test set. So for training data set, now with this 1,500 people, we can then try many different models. We can then try using like regression models. We can change parameters to basically try and iteratively find a model that can sort of fit the data like as best it can fit. And then we take this model and we test it on this unseen 500 people. And from this, we can then predict if the participant belongs to the US or Japan based on the model or based on the training data set that is learned from. And so if the cultural differences between America and Japan are very strong, we should then expect to see that this model, having been developed on this training data set, would also be able to classify if a participant belongs to US or Japan with a reasonably high amount of accuracy. And so what kind of models do I use? Earlier on, I mentioned using a simple regression model, which is great. But for me, I think for this kind of research, what I wanted to do was more using decision trees, because I can then take into account more complex interaction effects that might happen within the data set. So what is a decision tree? So this is, I think, is used more in economics and not so much in psychology. But we're basically trying to segment the data. We're trying to tear the data apart and to see if by splitting the data up, can we then get representation of participants who are Japanese and American. And so splitting the data, essentially, we're just trying to apply rules to it. Maybe we could look, for example, at language. So if the participant speaks Japanese, or if they speak English, maybe the amount of years they spent in the US, like a very simple kind of definition, like maybe a cutoff that the model can identify would be 3. So if you spend more than 3 years in the US, chances are you're American. If you spend less than 3 years, chances are you're Japanese. And so this sort of model selection and stratification process is quite automatic, and it's usually done to correspond to the lowest kind of error possible from the model. Now, as you can expect, having just decision trees like this, just a single decision tree would be a very biased kind of process, because you're splitting the data and you keep splitting it. And let's say if you have like 1,000 variables, for example, you have like 10 to 15, 20, 100 variables to choose from. Would the model always choose the same variables every single time? And because it's you're sort of splitting data up every time you go along. What happens is that you're just introducing a lot of bias into this kind of interpretive process. So for now, you might fit this model and this model, like decide to look at language and a number of years in the US. But the next model you fit might decide to look at things like personality, or to look at things like number of times they message a friend a month, or something like a random kind of different kind of variable. And so because of that, what we want to do is we want to use an ensemble method, which just fit many trees to try and look at this data set. And then we average the result. So if we were to do it simultaneously, this would be known as a random forest. But personally, I prefer using it sequentially. So we call it gradient boosting. And what happens then is, for each tree, we take the residual error from each tree, then we then put it back into the next tree, and we then slowly continue this process until it's supposed to stop. So with each iteration of decision tree, the model starts to get more and more suited to the data set. So for example, if we will have like just 2 dimensions, 2 predictive variables, let's look at how it would look like. Now, if we assume that this is a regression task instead of a classification task, just for illustration purposes, let's say like the first model we built only explains, like doesn't do a very good job of explaining the relationship between X and Y. And so we take the residuals of this model, we put it back in again to retrain the next model, and it starts to get a little bit better. Then we take the errors again, we put it back again, and then we train the third iteration, and then we start to see it starts to have a better representation of this relationship between X and Y. So it's the same idea for this decision trees, and we call this process gradient descent. So now we have got a model, right? We've got a data set. We can test it on the test data set for an idea of how strong or how big the differences are between cultures. That's great. Now we want to look at it a bit more. We want to understand why is it doing, or what are the differences? Where are people in Japan different from people in the US? And so while usually machine learning models are very black box, they're not very interpretable, that doesn't mean there aren't techniques that have been like invented to try and unpack this black box. And so I'll be introducing to you 2 different ones that I use, again, from my research. The first one is what we call RVI, or variable importance. And if you remember earlier on, I talked about using how the model automatically, like a decision tree, how it automatically decides which variable to stratify, which variable and which cutoff to stratify in the way to maximize or like to minimize the error for the model, right? So now if you keep doing it over time, we start to see certain regularities, like certain variables might tend to be picked a bit more by the model. And so really what variable importance does is that it looks at the number of times, like the overall percentage that these predictive variables are selected for stratification. So now we have like a list of which are more important, which variables tended to be looked at by the model a bit more than other variables. And then we want to see the direction of effect. So for this, we use partial dependence plots. Now these are basically a visualization technique. And so if you imagine, like, you hold all the variables constant in this model, and you just change one, like the target predicted variable across all its values. And then you look at like the corresponding error that it has. You see how just changing this one variable affects the prediction accuracy of this model. And so this gives you a sort of idea on how important that one variable is, as well as the direction. Like maybe if it's higher, it's a higher probability of being classified as US against Japan. If you're confused, I can understand it. It took me a while to get this as well, but I think I will just. I think when I go on to the examples, it might be a bit clearer. And so examples, right? So I looked at the world value survey data. I didn't look at the entire data set. I just focused really on the 10 shorts values within the weight stakes. I wanted to see if, based on these 10 values, because there's a lot of theory associated with this 10 values. So we can then have some kind of idea or some kind of interpretable framework that we can use to understand the results, right? So based on these 10 values, and based on like I think 2,000 people per culture, 1 or 2,000 participants per culture for the US, Japan, and China, I wanted to use a model to classify between the US and Japan and US and China, because there's a lot of comparative research looking at these two comparisons. So we are quite aware of the differences between these two cultures. So if this approach that I've been explaining, using gradient boosting, using decision trees, using cross-validation, if it's true, then we should be able to see consistent results in our model that can be understood in the context of previous literature. Then I also wanted to look at China-Japan differences, because what everyone talks about, comparing the East and West, not many people talk about looking at differences within the East. So we don't really have a good idea of how Japan is different from China. So people who have lived in these two countries might intuitively feel that it's very different, but there isn't a lot of research to kind of back that up. So this could be an example of how machine learning can be used to contribute towards our understanding of understudied cultural differences. And so we first need to process the data. Because machine learning tends to be very sensitive to noise interference. So we needed to do a few steps to make sure everything is in order. We first match the samples. We didn't want to have more than the other, just balance the data set. We also want to minimize response bias, so we centered it around the individual mean scores. This is not necessarily the best way to do this, but at the very least, we wanted to reduce the amount of response bias that we could. We also removed missing data, and then we did train test it for cross-validation. And so for results, we found that, quite interestingly, the US and Japan in US-China model had pretty moderate accuracy, which means there are fairly big differences between cultures. But interestingly, and I'll come to this later, the China-Japan model had higher accuracy than the US-Japan and the US-China model. I thought that was pretty interesting, which means that the cultural differences between China and Japan might actually be bigger than the US, Japan, and US and China. But I'll come to that later. Let me just focus on one by one, just to explain just to show you some of the results. So first of all, we're going to focus on the US and Japan. And so these are the list. I'm not sure if you can see my mouse. These are the list of variables that we use. And so these are the relative variable importance, which is the percentage that a certain variable has been selected for stratification. And we found that the most important variables were hedonism, benevolence, and universalism. And if you look at the partial dependence plots, now how you read this is that, so this represents score for hedonism, and this is a probability of the model classifying a participant as belonging to the US, which would be 1, or Japan, which would be 0. And so we find the higher the participant scores on hedonism, the more likely they will to be classified as American rather than Japanese. We saw the opposite pattern for benevolence, where the higher they were on benevolence, the more likely they were Japanese rather than American. And again, the opposite for universalism, where the higher they were on universalism, the more likely they were to be American. Now, this makes perfect sense because, these three um, domains, these three items are very well defined in literature. So hedonism, from IQ effect, where Americans usually want to maximize happiness. Benevolence, independence, Japanese are more interdependent. And universalism, we know that America, like the Statue of Liberty, is about freedom and equality of mankind. So universalism makes sense. It makes sense that like it would be higher in the US than in Japan. Like the participant would more likely to be in the US than Japan would tend to rate higher or like tend to score higher on universalism. Next, we look at the US-China model. We only found two really strong results. I'm surprised as well as how strong a result power is, which I think in this case, in the world value survey, tends towards materialism, but yeah, and for self-direction. And here, if we look at the results, the more likely, like the higher the participants scored on self-direction, the more likely they were to be American, because China now is a positive class. And the opposite effect for power, where like the higher the participants scored, like the higher the participants scored on power, the more likely they were to be Chinese rather than American. And again, this kind of makes sense in a different way from the US-Japan comparisons, because if we assume power to be materialism, we have a lot of previous literature to show that Chinese, especially at this point in time when a survey was taken, tended to be more materialistic than Americans, and this has a lot to do with post-Maoist reforms and reputations of faith in collectivism and interdependence. Self-direction, on the other hand, we talk about autonomy, creativity, independence, and very obviously this would be stronger in the US and China. But notice again that where China and the US are if you compare the differences of difference, the variables or the items that were present in this data set in this comparison were different from those that were highlighted in the Japanese data, which was hedonism, benevolence, and universalism. And so looking at the China-Japan model, we saw that, again, a different set of items were identified. So if for power, again, materialism, China seem to be more, have a stronger emphasis on power than Japan. But for hedonism and benevolence, I thought it was interesting because for benevolence, like again, the higher they were on benevolence, the more likely they were to be Chinese. And for hedonism, more likely they were to be Japanese. Now, how do we interpret this? So one thing I think that maybe this makes sense because perhaps Japanese people could value more subjective well-being and indulgence more than Chinese, because a lot of the emphasis is on perhaps being hardworking in China and being very competitive in Chinese society. That kind of makes sense. And for benevolence is interesting because it seems to suggest that Chinese people might be more benevolent, might be more independent than Japanese people. So to be honest, I'm not really very sure how to interpret this. I didn't go down the research on wanting to compare China-Japan differences, but I think some of you might be interested to know that we cannot just treat East Asia as one homogeneous block. There are differences between cultures within East Asia, and sometimes these might even be bigger than the difference between Japan and the US. So I'm going to leave this here. I'm going to move on to talk about machine learning again, some of my ideas. But if you're interested to know more about China and Japan differences, like come and talk to me after this. Okay, so we talked about culture differences. And what I thought was very interesting is that now we can know how machine learning can be used for new theory generation, because if we don't really understand Chinese-Japanese differences, we can then use machine learning to identify those differences and perhaps develop new theories that we can then test with follow-up research using cross-cultural samples. Okay, so now we know that sort of like if you compare between two countries on a data set, you get overall approximation of how far apart they are from each other. Now, what happens if you compare all the countries in the World Value Survey, all 60 of them, for this shots? And so this, if we compare all of them, we have this huge matrix, and then we can then average it by country. And I think what we refer to as value globalization is there when we can then get an index, a score of how each country is unique or connected to the global average. Because we're looking at all possible combinations of cultural differences in this data set, like dyadic 2x2 cultural differences. And so if we were to look at some of these correlations, well, before we look at correlations, this is just a visualization of like how globalized they are. So here, the lower the score means that the model wasn't able, on average, wasn't able to predict, classify those countries very well, which means that they are seem to be more connected to the global environment. Whereas the higher the score means the model had no difficulties with classifying the data, which means that they're more likely to be very culturally unique or culturally distinct. And so we looked at possible explanations of this. We looked at correlations with some external kind of indices. And we found that trade, particularly import of goods and services, tended to predict this globalization, this value globalization. So countries that were high on this value globalization, that were more connected to the rest of the data, they tended to have higher values of trade. So my interpretation was that this could represent the inflow of produce, the inflow of goods and services, because along with inflows of trade, you get a lot of values. You get a lot of additives from these places that sometimes are embedded in aesthetics. And so when these come in, it could then shape sort of the culture of the country. But bear in mind that we use decision tree-based methods, and these are sensitive to higher order interactions. And so this might not be the best way to look at it. Maybe using different models or using some other kinds of machine learning models might be a bit better for this. Sort of to validate this approach of comparing many different countries, I also looked at cultural distance. And so this is really based on an idea by, I think, Michael Muthukrishna in this 2020 paper in Psych Science, where he introduced this cultural fixation index, which does this very similar thing, but using methods from evolutionary biology based on the fixation index. But I would argue that this machine learning method that we use, it offers more interpretability, because we can then look at things like RVI and PDP. So we can see, like, for each possible comparison, we can then understand what are the factors, what are the variables that accounted for this kind of differences. So we then, because for Muthukrishna, he looked at cultural distances from the US and from China. We also look at differences from the US and China, and we compared them. Bear in mind that while Muthukrishna, his paper looked at all variables in the world value survey, we only look at Schwartz values. But even then, for the US index, we managed to replicate quite well some of the things that he found in that data set. Very interestingly, China did not replicate, almost like nothing replicated. And I think this could be because I mentioned earlier in the introduction that a lot of these theories tend to be very westernized. They tend to embody like Western ways of thinking about culture. And so maybe Schwartz values, Schwartz, the cultural values, his ideas of his data sets might be more skewed towards representing the Western ideal and might not be able to get this whole Chinese idea of culture. Again, this is not something I've looked into in a lot of detail. It's still a work in progress on my end. But I thought it would be interesting to just share that machine learning can be used for this kind of approaches as well. So in some, to cover the first part of my presentation, machine learning, basically when we put culture as the target, as the outcome variable in machine learning models, we can then, using metrics like classification accuracy, we can then measure the magnitude of cultural differences. And using tools like RVI and PDPs, we can then go into these models to understand where the differences are, like what is going on back there. I think where it can be most useful is when we want to look at a very quick and very dirty look at cultural differences outside weird spheres. Like we want to compare between, say, I don't know, maybe cultural distances from Turkey, for example. Just to get an idea of what are the unique traits of that country. And moving beyond like machine learning on survey data, I think the next thing I want to introduce to you is how we can then take advantage of a lot of these kinds of big data that exists on the internet, and then to try and feed back into our understanding of culture and cultural differences. And so for this, I'm going to be talking about the next part of research where I basically look at Spotify data to try and understand how danceability, which is a feature on Spotify, musical feature on Spotify that reflects rhythmic arousal, how it can actually be used to represent anger or high arousal negative emotion affordances by culture. And so like I mentioned earlier in the previous study, world-variety surveys are survey data, and questionnaires and surveys are kind of like the bread and butter of us cultural psychologists. But if you look beyond these kinds of survey data, if you look at like web footprints, you look at in cultural products, there's a lot of sense behavior, a lot of interactions that are left online. Like you have product reviews, you have social media, and in this research you have music consumption and production. And so these sort of online behaviors, they embody intangible cultural values because being popular products, and that influence aesthetics and behavior. And essentially with like the web data, you have huge online repositories of these data. And I think using machine learning, we can then, which is best suited for big data, we can then take this out and then just pull it apart and try and understand in theory and generate theory for how cultures are different. And so focusing on music is something that is very prevalent across cultures and history. And so there's a bit of a debate here, but generally, the way human beings perceive music is quite universal. So if we assume it to be universal, we know that, a song coming from India would sound very different from a song coming from, say, Western classical music. And so any kind of differences in sort of the music that emerges in the culture often represents differences in music preference. And if you borrow on the music preference literature, we know why do people like listening to different kinds of music? A lot of the time it has to do with identity. It has to do with affect, mood, emotion regulation. And so it could be very possible that if we can then pull apart this kind of data, we can then learn something about how people are different from each other in terms of the mood and the emotions that they experience. And so that was like kind of where I wanted to hit into, because we know that, emotions are experienced differently across cultures. You have affect valuation theory, where people want to experience different kinds of emotions and moods across different cultures. You have differences in cultural affordances for emotion, like some cultures like facilitate engaging emotions, some cultures facilitate disengaging emotions. And so this all comes down to affect regulation, because if you listen to music for affect regulation, and this is a huge reason why people listen to music, people come from different baselines and different target emotions. And so this should basically influence music preference in some way. But what way? We don't really know. We know that some form of music should reflect some form of culture, but we don't really have a good theory on what it is and where it is. And so this is where I thought machine learning would be a perfect way to generate theory. You can run an exploratory analysis on a huge data set, brainstorm some ideas from looking at the PDPs, and then come up with a theory that could represent these kind of differences across culture. And so for study one, that's what we did. We combed through, using Spotify API, we combed through music that was produced in Japan and music that was produced in the West. And Spotify has a database of different music features. I'm not going to go into all of them, but I'm going to focus on danceability, because ultimately, a bit of a spoiler, this is what we ended up focusing on, danceability, which is basically the rhythmic salience, the rhythmic arousal of a piece of music. And so what we did, we scraped all related artists through a pseudo snowball sampling method using Spotify recommendation algorithms. Then we ended up with about 1 million songs, 500,000 for each culture, that we fed into a machine learning model. And then with an accuracy of 0.75, we managed to see a decent amount of difference. And then we took the top 5 sort of variables that, based on RBI, that we then looked at the PDPs. And so here we wanted to focus on emotion explanations, because our idea was to look at affect regulation, right? So we looked at danceability and instrumentalness, and energy as well, but energy we left out because we didn't know how to define it. But I have another paper that I won't go into that looks at energy, but so if you're interested in energy, we can talk about it later. But for now, for this presentation, we focus on danceability and instrumentalness at this time. Because instrumentalness, is quite low arousal, whereas danceability represents, dancing, which is more high arousal kind of movement. And so because our study one looked at, our machine learning study looked at music produced by a culture, we also wanted to examine if this translated to music that was consumed by cultures. So we looked at 4 East Asian countries, we looked at 4 English-speaking Western countries, and then we hypothesized that, what we found with instrumentalness and danceability should also be present in these countries, in this cultural comparison of charts. And we did find that danceability replicated very well because Western cultures were higher on danceability, which is, if you look at the PDPs, it's kind of the similar direction. But instrumentalness, we saw a slightly opposite effect. So because we're not quite sure what is going on with instrumentalness, we decided not to focus on it. So instead examine danceability or rhythmic arousal. And so now we've narrowed out our area of focus. We can start to think about hypotheses. So danceability might reflect high arousal. We don't know if it's positive or negative, but just high arousal emotion experiences across cultures in some way. So we hypothesize that the more a culture is accustomed to high arousal emotions in their daily life, the more they would prefer danceable music. Because if you look at the US and Japan, high arousal emotions are much more prevalent in the US than they are in Japan, just by going by affect variation theory. And so what we did next was to then look at arousal in music preferences between the US and Singapore. The US being a very independent country and Singapore being an interdependent collectivistic country. So we had a similar hypothesis. We hypothesized that high arousal emotions will be stronger in the US, but low arousal emotions will be stronger in Singapore. This is for music, by the way. And then we hypothesized that individuals in the US would prefer music for, to dance to music because danceability is about dancing, and then individuals in Singapore. And we also looked at independent of their cultural background. We also wanted to look at their orientation towards independence and interdependence. And so we looked at different kinds of, two kinds of music listening contexts. Active means, just nothing but listening to music. Passive means listening to it in the background. We found there was no differences there, so we averaged scores between them. And then we got them to basically imagine listening. If you were to create a playlist, what kind of music would you put? Based on a list of high arousal descriptors, what kind of, how would you rate your playlist on these descriptions? And we found, because a lot of these descriptions had to do with arousal, high arousal descriptors were much more prevalent in the US than in Singapore, as well as listening to music for dance functions appeared to be a lot stronger in the US than in Singapore. We saw a similar effect with independence controlled for culture, where on an individual level, if you're more oriented towards independent thought, independent orientation, you're more likely to prefer listening to, preferring high arousal music, as well as on a trait level, preferring to dance to music. For our next study, we went again back to Spotify data. We didn't want to look at just East-West comparisons. We wanted to look at as many countries as we could, try and see, because danceability, does it generalize beyond just the East and West, which we were looking at so far. And so we had macro level emotion, which in this case would be World Happiness Report, World Happiness Indices of negative emotion frequency, which is for the participants of this World Happiness Report, World Happiness Survey, in a day before coming to take the survey, did you experience this bunch of negative emotions, or did you experience this bunch of positive emotions? And we also control for alternative explanations. We control for GDP, migration, investment, colonial history, Hofstadter scores, and tightening looseness. We also wanted to make sure that our understanding of danceability wasn't just limited to Spotify, because Spotify isn't very clear about what they have for danceability. So we also had our own open source measures of danceability using DFA, which sort of looks at the stability of the waveform, and model predictions from a pre-trained neural network model that was previously trained on danceable tags from this big data set of human annotations. Anyway, we found that no matter what model we tried, negative emotion frequency was a very, very strong predictor of that country's danceability charts. And when we look at the replication, it was strongest in the neural network danceability and not DFA danceability. But interestingly, we didn't find any effect at all of positive emotion frequencies. Now, what do we make of this? What do we make sense here? Something that we noticed was that like high danceability countries and high negative effect countries, they tended to be focused a lot more in Latin America and the West. And so our understanding was that maybe in these countries where you have a lot of high amounts of negative emotions, you might want to listen to danceable music, which is naturally a very high arousal kind of music, to downregulate those emotions, to cathartically release your anger or your high arousal negative emotions. And so we compared between Japan and the US using a participant study where we looked at affect valuation. But in this case, we're looking at a high arousal negative actual index using descriptions of like fearful or hostile. And then we also looked at the brief music and mood regulation. In particular, the discharge regulation, which is a measure of cathartic listening, of like the individual's dispositional usage of discharge regulation when they listen to music. And what we found was that in the US, people were more likely to use discharge regulation than in Japan. And even when we controlled for culture, we found that people with high experiences of negative emotions were more likely to rely on discharge regulation in music. And so with this sort of mini discussion, what we think is going on, what our theory is that danceability seems to reflect some kind of anger emotion experiences across cultures, or like high arousal negative emotions across cultures. So the more the country experiences anger or other kinds of high arousal negative emotions, the more they prefer danceable music. And one reason that we think this is happening is because people are more likely to engage in cathartic listening to downregulate these negative emotions. We didn't find any relationship between danceability and positive emotions, which was quite surprising. But yeah, it seems to be some kind of effect regulation process through music listening. So here we found that machine learning was useful in establishing the magnitude of cultural difference, because in the first study you can see it, with a moderate score of 0.075 accuracy, is a pretty decent amount of difference between US and Japan. And then using our feature selection process by looking at RVIs and PDPs, we were able to identify danceability as a major component of cultural differences, a major feature of cultural differences. And this was consistently replicated across the 4 studies of this data set. And so trying to bring everything back together again, what we found was that machine learning was generally successful for the different tasks that we wanted to do. In all cases, I think we need to have follow-up confirmatory studies to try and prove that the results that we found were not due to like sample biases or model biases, but really a generalized effect that we can identify from that culture. But practically speaking, what we found that really helped was that using machine learning helped us to develop theories, develop new ways of thinking about cultural differences. And one possibility is because of the conservative nature of machine learning, might be useful for the replication crisis. I'll leave it there. I'm not taking myself. For this series of research, one big limitation was that culture was always defined as a country-level construct. Now, this is not always the case, but this was the approach that I used for my research. Also, with web data, not everyone uses a specific service. In this case, we use Spotify, but not everyone uses Spotify. Sometimes depending on what culture you come from, like the platform you use can be different. Like I think in Europe, I think Deezer is very common, and I think if you go to and there are things like Apple Music as well. And so all in all, what I'm trying to say is that machine learning and the method that I use here, it does not replace traditional hypothesis testing. We always need to examine correlations. We need causal inference. We need A/B experimental testing. But machine learning could be a way to complement these kinds of research to develop new ways of thinking about data, to develop new theories. One caution as well is that results are not always stable. Different models have different things. So the common approach that engineers like to use is that to try to model using several different kinds of machine learning models to see if the results are consistent and always true across models and data. So machine learning here, as I mentioned on theory development, it can sometimes be an alternative to its observational studies or qualitative studies. Most of the time it's very cheap to run. And because of today's online world, a lot of data is just stored online. Machine learning is really best suited for analyzing these kinds of big data. And so with this, I hope I introduced a kind of framework to use machine learning in your kind of workflow, in your research workflow. And future research, what I'm proposing maybe we can look at different kinds of state-of-the-art models such as transfer learning or deep learning, because gradient boosting that I use here is quite an old approach in the machine learning literature. And so with that, I come to the end of this presentation. Thank you so much for listening. I hope that this has managed to give you some ideas on how alternative data-driven techniques can be used for cultural psychological research, of which machine learning is one of them. And if you have any questions or any comments, you can contact me, DM me on Twitter, or we have some time after this talk, and I'll be very happy to discuss this in a lot more detail. Thank you very much.